Okay, some problems dealing with the area of a trapezoid. As we went over in class, the area of a trapezoid can be stated as the median times the height, which is the way I prefer to say it, or you can say 1/2 times the height times the sum of the two bases, as the book states. We'll see how this works out. First problem, if the top base is equal to 10 and the bottom base is equal to 14 and the height is equal to 4, that's the green segment over on the side because it's perpendicular to the two bases, and we'll write down area equals the median times the height. So the area equals the median, we'll go off to the side and find the median, it's the average of the two bases, add and divide by 2. So 24 divided by 2, the median is equal to 12. Times the height, which is given as equaling 4. 4 times 12, 48 is the area of the first trapezoid. Next problem. Area equals the median times the height. So in this case, the area is given, that's 45. The median is the average of the two bases, so just like before, we'll go off to the side and find the average of 8 and 10 and divide that by 2. Well, we'll find the average by adding and dividing by 2. So we have 18 divided by 2, the median is equal to 9. Times the height, which is the answer to the question. So if 9h equals 45, we divide each side by 9, and we have h is equal to 5. So segment AE is equal to 5. Next problem. We'll start by writing down the formula again. And I really encourage you to write down the formula every single time, whether it's this formula or the other one. So we have the area, 50, equals the median, which we don't know, times the height, which is 5. So even though m is not the answer to the question, it's going to help us find the answer. We divide each side by 5 and we find the median is equal to 10. Now the median is the red segment, and the segment at the top is equal to 9. The median we just found is equal to 10. So x, the answer to the question, segment CD at the bottom of the diagram, the 10 has to be the average of the 9 and the x. So you could state 10 equals 9 plus x divided by 2 and solve for x. What I'd rather do is say going from 9 to 10, that segment has been increased by 1. So therefore going from the median to the other base, it has to increase by another 1 so that the 10 is exactly in the middle. And 10 plus 1, the answer to the question is 11. Next problem deals with a rhombus. Now the book introduces yet another formula, 1/2 the product of the two diagonals. The problem I find with this formula is not many people remember it, even a few months later, but most people remember that a triangle is 1/2 the base times the height. So if we look at the rhombus as being 4 congruent right triangles, I've just shaded in one of those, triangle ABE. If you look at that triangle, if we can find the area of that triangle, we simply multiply it by 4, as stated down here. So we'll do this problem two different ways. The area equals 1/2 the product of the two diagonals, the new formula. 1/2, one diagonal here is 8, the other diagonal is 6. They're interchangeable, it doesn't matter which one's first. 1/2 of 48 is 24, which is the answer to the question. So yes, that's the faster of the two ways of doing the problem, but it's less likely, or I should say more likely, that you're not going to remember 1/2 the product of the two diagonals, as opposed to remembering that a triangle is 1/2 the base times the height. So I'm going to find the area of this triangle. Because it's a right triangle, one leg is going to be the base, the other leg is going to be the height. So if BD is equal to 6, if that entire segment is 6, then BE has to be half of that, which is 3. Likewise, for segment AC, if segment AC is equal to 8, then 1/2 of that segment, or segment AE, is equal to 4. So looking at that one triangle, we have the base is equal to 3, the height is equal to 4, 1/2 of 12 is equal to 6. But that's only one triangle. There are 4 congruent triangles, all of area 6 square inches, square centimeters, whatever the unit of measure is. So therefore the area of the rhombus is 4 times that one triangle area. So you still get 24. Same answer either way. And we'll do one more problem for today. For a regular polygon, the book states a formula that we're not going to bother to use. It's 1/2 the apothem times the perimeter. But we're going to find the answer a similar way to which we just did the rhombus problem, and that is to say, if we can find the area of one of these 6 triangles, the area of the hexagon is just 6 times that, because there are 6 congruent triangles. So I'm not going to bother with this formula. I'm going to say the area of a triangle equals 1/2 the base times the height. So all of these triangles, we have proved in class that they're all equilateral triangles, so I'm just going to draw one of them here. Could be the triangle I have shaded in at the bottom. But if one side of the regular hexagon is equal to 4, they're all equal to 4. If one side of this equilateral triangle is equal to 4, they're all equal to 4. If we draw in an altitude for that triangle, it's going to intersect at the midpoint of the base. That's the case for all isosceles or equilateral triangles when you draw the altitude perpendicular to the base. So therefore this segment over here is 2 and this segment is 2, and we can solve for x a couple of different ways. We could use the Pythagorean theorem saying 2 squared plus x squared equals 4 squared, looking at, say, this right triangle over here. Or we could recognize that it has to be a 30, 60, 90 triangle, and the shorter leg times 2 gives you the hypotenuse. The shorter leg times the square root of 3 gives you the longer leg. So in this case, that would be 2 times square root of 3. But that's the height of the triangle. So going over to my formula for the area of a triangle, I have 1/2 times the base, which is the 4 right here, times the height of that triangle, which is the value for x, which we just found to be equal to 2 times square root of 3, and we carry out that multiplication. I like to cross out the 2's and say 4 times square root of 3 is the area of one triangle. But there are 6 triangles, so times 6 gives us 24 times the square root of 3 for the area of that hexagon, regular hexagon. Hope all of this helps for the next quiz. Good luck.